Two and a Half Admins, episode 185. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. Last time we talked about privacy. This time, let's talk about AI. Jensen Huang says kids shouldn't learn to code. They should leave it up to AI.
Gee, what a strange thing for a guy running Nvidia to say.
Yeah, it's not like they have a vested interest in selling hardware to people who do AI bullshit or anything.
Yeah, but at the same time, doesn't Nvidia need to be able to hire people to write the AI stuff?
No, the AI will do that.
Yeah. Presumably, Wang is trying to talk to the kids who aren't going to grow up to be the kind of engineers that Nvidia needs or wants, because AI certainly isn't doing that kind of job anytime soon. Presumably, he just figures he's kind of screwing over the next generation for, I guess, lower-end coders and just turning over low to mid-range coding to AI. But you can't rely on AI for that either.
Yeah, you can rely on it to help you out, save you some time, but you still need the skills to understand what it's spitting out at you.
You can rely on it to give you ideas, is what you can rely on it on. But whatever ideas it give you, they need to be thought of that way. Ideas, untested, unproven, that you need to check. And in many cases, that can still be, a huge efficiency win, productivity win. An AI tool can break you out of just like a brain lock where you can't think of the thing you need to think of, and you need some new data to just kind of jog the gray meat. Sometimes AI can help you by producing a whole bunch of boilerplate crap that doesn't change much from one thing to the next. And it's like a huge mental or emotional or energy drain for you to sit there and type it all out. But if it just gets barfed out in front of you, you're competent to scan it and see this is correct or not correct. What you really can't do with AI and code is say, hey, AI, write this code for me, and I'm just going to hit save and run it.
Yeah, I'm specifically talking about boilerplate stuff that, like you say, it's just typing out loads of stuff and it just goes blah, instantly saves you, 30 seconds.
But again, you really can't use it for that unless you understand the boilerplate stuff, because it won't always get that right either.
Yeah.
So if you can't catch and correct an error in the boilerplate stuff faster than you can type the boilerplate stuff out, it's still kind of a lose.
Everybody in the world isn't going to be a coder, and every single kid isn't going to either. But I still think there's value in them understanding some of the concepts of it. And I wish I had got introduced to the concepts in a more formal way earlier in my career, rather than, I learned to program by downloading QBasic code from the local BBS and reading it and muddling with it and learning the hard way. And then by the time they started trying to teach the basics of programming in high school, it's like I was running circles around that.
Yeah, and you accidentally became a developer because you were a sysadmin originally, and then you sort of just accidentally became a developer.
Whereas I thought I was going to be a software developer my whole life, and then discovered, no, actually turns out I'm a sysadmin.
Yeah, for me, it was a little bit like I thought I was going to be a software developer at first as well. But then in high school, I did a job placement at the power plant as a sysadmin, and I really enjoyed that. And then when it was time to decide what to go to school for, it's like, well, all the programming I know, I taught myself. Or I can read from a book and I can do with my one computer. But to be a sysadmin, I need a lot of computers. And guess what the college has? A whole lot of computers I can go and futz with. So that's what I'm going to school for, because that's where I'm going to actually get more value from the practical side of it.
Alan, you are a pretty pragmatic guy. Have you tried GitHub Copilot, for example?
Not the Copilot one. I've used ChatGPT to help come up with ideas for articles to write, or how to structure a presentation, or how to just say something, or questions to ask during job interviews, and lots of ideas, like Jim was saying, asking it, here's some things I've thought of, think of 10 more for me to help me fill out this list. And it's reasonably good at that. You need to also apply a critical eye and edit it a bit and so on, but it can really be a time saver. But for source code, it's like with what I'm doing in the source code, honestly, it's probably not going to be as helpful. Or my biggest concern still is, what is the license of this code going to be? Because if I'm selling this code to people, I have to be able to rightfully claim that I wrote this and that I have the authority to sell it to you and that it isn't some other code.
As far as Wang's idea saying that, kids should learn AI instead of coding or whatever, I think the big thing here that keeps getting me about that is the issues of like who wrote it, who owns it. Is it clean in terms of the bill of materials, whatever for AI written code? Even when you put all that stuff off to the side, just the idea that do it with AI instead of doing it yourself, I kind of have the same advice there that I give people all the time about scripting. I see, larval folks all the time writing these really long scripts to chain together, 20 or 30 simple tasks that they don't really understand the individual tasks very well yet. And yeah, they may very well be able to put together a script that ties all those 20 or 30 things into one script that they can run to do that thing over and over again. But you haven't learned how to actually do any of it. And if you lose that script, you're screwed. And there's a lot of things you don't understand. My advice is do those 20 or 30 things manually, frequently enough, often enough that you've got no problem just doing it all off the top of your head. Then write the script, because you don't need to do those things anymore because you know them, you understand them, you know all the steps, you can do them without the script. That's when you look at, okay, let me take the script and automate this, and that will save me some time. Using AI in a coding context should be a pretty similar thought process, with the added caveat that unlike the scripting, which guaranteed will do the same thing every time, AI is not guaranteed to do the same thing every time, almost certainly won't do the same thing every time. It is partially random in the same way that, a human being or a well-trained dog is partially random. That's the whole point. You didn't have to program it. You could just give it a loose idea of what you wanted it to do in a sloppy, imprecise human language, and it would mostly do what you mostly wanted. So it's like anything else. When that's the degree of accuracy you have from the person on the top to the person next down the chain, stretching our terms a little bit and granting, some large language model the title person. Still, the point is, it's imprecise, so you have to supervise in a way that you don't as much with code, because you can find out whether the code is buggy or not, and it'll operate the same way, and if you're doing the same thing, it'll do the same thing. And again, with a model, not so much.
But it may be taken from a different lens. If what Jensen was trying to say, or maybe just a thought I'm having, is rather than every grade schooler learning Python and only some of them going on to actually do development, if we taught them how to use AI properly and what its limitations are, that might be much more useful to a lot of them that aren't going to become developers. The skills of how to use AI to get prompts for creative writing or art or all the other things that AI can be used for, it might actually be a more valuable skill than force-feeding Python to every grade schooler.
See, what I hear you saying, Alan, is kids should also learn to use AI, which I would agree with. What Wang said is kids shouldn't learn to code.
Well, yeah, he says it is our job to create computing technology such that nobody has to program, and that the programming language is human. Everybody in the world is now a programmer. This is the miracle of artificial intelligence.
And it will be every bit as reliable as just offhandedly telling your kids to go do something and then walking off and coming back 4 hours later to see if it's done.
Well, you know what this reminds me of? It reminds me of stuff like Dreamweaver back in the day, where you could make a website, but anyone who knew about making a website would look at the code that Dreamweaver spat out and go, oh, this is horrible. I mean, yeah, it kind of works, but it's horrible code.
Same thing with Microsoft's front page. I remember that, and you bold something and then change it, and later and there'd be like a open bold, close bold tag around nothing, and just all kinds of detritus in the code. It was very useful as a learning tool in that you could use the WYSIWYG to get something and then look at the source code side and figure out how it did it. But as soon as you understood any of it, you're like, why is it doing all this other stupid stuff?
I used to use front page as a WYSIWYG editor, and I would actually write the code in HTML in the source window, but just the fact that it would render in real time as I was doing it was invaluable because you didn't have a dev console in a browser to do that with back then.
Yeah, it's I don't know how we ever did CSS without the developer tools in the browser.
With great difficulty and much angst.
Well, especially back then when it's oh, you have to upload it somewhere before you can view it to have it all work correctly. So you edit the file, save the file, copy and paste over FTP to somewhere, and then go to the browser and hit refresh for every single edit. And the round trip time was terrible.
Especially when it was CGI bin stuff and you literally couldn't do anything with it on your own computer. So you're editing, these 1,000-line code files on your own machine and then FTPing them up over dial-up to a server on the other end of the country, and then hitting a web page that would hopefully run your code, maybe put out the thing that you wanted. Oh, that sucked. God, that sucked a lot. I do not miss those days.
Well, what about Google cuts a deal with Reddit for AI training data, and also Automatic, the company that owns Tumblr and WordPress, is going to sell users' data to Midjourney and OpenAI. It's disappointing, but again, it's not surprising, is it?
Not really, and I think we're going to see more and more of this. The kind of interesting thing is a lot of these places probably didn't have a good cutout for this in their terms of service. They usually are generic as possible so they can get away with anything, but I think you might start to see this specifically in terms of service going forward, saying, yeah, we could use this data to train our own AI or sell it to somebody else who will. But I see a lot of places deciding that, hey, this stuff we have, maybe somebody will pay us for it, and going and doing that. And I think it's terrible, but I also think unless we make a really big stink really quickly, it's going to happen a lot.
I mean, Jim, you wrote hundreds of thousands of words on Reddit, helping people out with their various ZFS problems and whatnot. You must feel pretty bummed out that that's just being sold to some AI company.
This may surprise you, but actually that part doesn't bother me so much.
Well, I would say specifically, you wrote those things in public to be public for the purpose of it being publicly consumed, right?
Exactly. I wrote those things on a very public forum with the idea that anyone who wanted to could learn from it. And that includes via AI model. Again, I will point out that AI models learn. It's not really that different from the way non-artificial intelligence learns. They train on data. I'm not mad about somebody learning from the things that I said online because that's my whole goal is I want people to learn from it. What I was mad about was the heavy-handed actions of Reddit itself, just screwing people over and yanking the API away from, a third-party ecosystem that literally had to grow up because Reddit itself wasn't producing usable apps, and just the high-handedness. The biggest thing that got me as mad at Reddit as I was not even yanking the API. It was when I saw what Spez had to say about it. When I saw the leaked internal memo that talked about, the user base is noisy, but just write it out. I was like, oh, that's how it is, huh? We're just noisy and inconvenient resources that won't just sit there to be quietly exploited however you want. We actually insist on having some kind of a voice? Okay.
Yeah, and I think it'll be interesting to see the details if they ever do come out about, is Reddit just providing a version of that API where Google can, in a way that's less costly to Reddit, scrape all the text of people's posts? Or is this also including more metadata, like when they posted and how they posted and how people interacted with each post? If it's just give us all the posts, then people made these posts in public Reddits, and maybe it's not that big of a thing, and Reddit does have the right to that content. But when it says selling users' data to train AI, that smacks to me slightly differently than just selling bulk access to the content that Google could go and scrape from Reddit. Normally, it would just be much more efficient for Google and less costly for Reddit if they use the API to get it.
I think ultimately, if this is something that we care about as a society, we have to actually do something about it. Whether the we as consumers or the we as the government that, the consumers elect, whether the pushback is, laws that say you aren't allowed to do this and we will throw you in jail or make you unable to do business in our country, or whether the pushback is consumers refusing to buy or pay for things, there has to be actual pushback that matters, or companies aren't going to stop. The phrase is don't leave money on the table, and it's around longer than any of the three of us have been alive or than any of our countries have existed. That is human nature. You get people in the business of making money and they want to make more of it and they find a way to do it. And unless something slaps their pee-pee in the door and makes them think that's a bad idea, they will. Because otherwise they're, and I'm doing the scare quotes here, leaving money on the table.
Okay, this episode is sponsored by Kolide. What do you call an endpoint security product that works perfectly but makes users miserable? A failure. The old approach to endpoint security is to lock down employee devices and roll out changes through forced restarts, but it just doesn't work. IT is miserable because they've got a mountain of support tickets, employees start using personal devices to get their work done, and executives opt out the first time it makes them late for a meeting. You can't have a successful security implementation unless you work with end users. That's where Kolide comes in. Their user-first device trust solution notifies users as soon as it detects an issue on their device and teaches them how to solve it without needing help from IT. That way, untrusted devices are blocked from authenticating, but users don't stay blocked. Kolide is designed for companies with Okta, and it works on macOS, Windows, Linux, and mobile devices. So if you have Okta and you're looking for a device trust solution that respects your team, support the show and go to kolide.com/25A to watch a demo and see how it works. That's KOLIDE.com/25A. Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember that for various amounts on Patreon, you can get an advert-free RSS feed of either just this show or all the shows in the Late Night Linux family. And if you want to send in your questions for Jim and Alan or your feedback, you can email show@2.5admins.com. David writes, I'm considering an upgrade path for my current router setup. At the moment, I'm using a Linksys WRT 1900 ACS router, which has a few 1 gigabit ports for WAN and LAN. I don't have a 1 gigabit internet connection, so on that side, the speed of the 1 gigabit router is plenty enough. In a medium-term future, I will be adding a NAS to my network, and I'm wondering how I could upgrade the link speed to 2.5 gigabits or more. If I add a 2.5 gigabit switch and I connect most of the wired devices directly to the switch, would they be able to communicate at 2.5 gigabits between themselves, or will the router limit the link speed to 1 gigabit?
The short answer is yes, that's perfectly fine. Matter of fact, you're already doing that, whether you realize that or not. Every gigabit switch out there will also handle fast Ethernet at 100 megabit, or the old 10 megabit Ethernet even, all just fine. All the devices on that switch will speak to each other at the highest speed that their individual link connection allows. The only thing that I would warn you of here is, and this is probably obvious, and you've probably already thought of this, it's not a real issue, but just in case somebody hasn't figured this part out, if you're thinking that you've got super fast Wi-Fi clients and they'll get a benefit of that at 2.5 gigabit, well, in that case, then yes, your router or access points had better also have 2.5 gigabit wired ports, or else you're not going to see any of that theoretical speed up. Not that they probably ever were going to go anywhere near that fast anyway, because that's all marketing hype.
Yeah, you've got to just consider what is connected to what. And if it's a 2.5 connected directly to another 2.5, whether that's a NIC in a desktop and a switch, then that's going to work. But if you have, say, a 2.5 port connected to a 1 gigabit switch that is then connected to another machine that is 2.5, you're only going to get one.
Yeah, and it's slightly more complicated. Like in a switch, it's kind of virtually creating circuits between every port to every port. And so, yeah, all the ones that are linked at 2.5 gigabits will be able to talk at 2.5 gigabits. Although in general, other traffic, like if there's a broadcast from one of the 1 gigabit ports, that's going to possibly limit the speed, but only for like microseconds and so on. And so in general, it shouldn't be a problem. Higher end switches can do some amount of buffering to try to smooth it out, but that's usually A, a much more expensive switch than you're going to have, and B, a complete waste of time at your house. At my house, I have a switch that has a mix of 10 gigabit and 1 gigabit machines, and my desktop and my NAS can talk at 10 gigabit just fine. And, the other 1 gigabit clients on the network can also talk to the NAS just fine. And, 2 different 1 gigabit clients can talk to my NAS at 1 gigabit each, because the NAS can deliver to the switch at 10 gigabits.
With that said, you probably should not expect to be able to feed 2 gigabit clients at full wire rate from one single 2.5 gigabit connected system. Alan might disagree with me here, but I've only had limited experience with 2.5 gigabit. It has not impressed me.
I think my desktop has a 2.5 gigabit port, but it's not hooked up to anything because I installed a 10 gig NIC and ran it to the other thing. So I don't have any real experience with 2.5 gigabit either. Honestly, most motherboards now sometimes even have a 2.5 gigabit PHY, but it's actually exposed out as just 2 1 gigabit ports, which is an even weirder configuration. So yeah, I wouldn't expect to be able to do that too much simultaneously, and it will really depend on your switch how much you can actually do the kind of multiplexing. But you'll be totally fine to only upgrade some of your devices in this case. Like you said, your internet connection is only 1 gigabit or less than 1 gigabit, so you don't have to replace your whole router just because you want your desktop and your NAS to be able to talk at more than 1 gigabit.
Absolutely. My recommendation here would be absolutely play with this. Understand that all you have to do is buy the switch. You don't have to spend a ton of money, and just, I would advise you don't expect too much out of it, which if you're not spending a ton of money is not really a problem, right? Like you put the stuff together, you see what it'll do, and now you know, and now you're a better admin or hobbyist or whatever you like to call yourself because you know more stuff. You've seen it happen, you know how it works, and that's totally cool. What I just don't want to see anybody doing is being like, well, I think I can scrape together the $400 or $500 for this project that, I expect to get these big benefits out of. Like if that's the thought process, I'm going to say maybe don't do that with 2.5 gigabit. Because again, I don't have a ton of experience with it, but I've seen it in action a couple of times and not seen a whole lot more than 1 gigabit of real world throughput through it. And the fact that you never ever see 2.5 gigabit stuff on anything targeted for business, it's always like home and gamer oriented. And, in business, you go straight from 1 gigabit to SFP plus and 10. There's no in between there.
Which I honestly found a little bit weird because the whole point of the 2.5 gigabit standard was take advantage of the 1 gigabit copper that's already in the walls of your office and not have to restructure your office. But I think it, like Jim's saying, maybe it just never delivered because I've not seen it have any adoption on the business side.
Well, it's one of those things also, like, every time we have a big bump up in network speeds, you never get them in the first few years. Like you get better than the last one, and that's really what you get. When 10 gigabit first dropped on the scene, like nobody was getting 10 gigabit. They were getting 2 or 3 and they were happy about it. When gigabit first dropped on the scene, nobody was getting gigabit. They were getting like 500 or 600 megabit and happy about it because again, that was 5 or 6 times the 100 megabit. As the technology matures, you get closer and closer to the theoretical wire rate in terms of the actual wire rate throughput of data that you get. So that now these days with gigabit, even on just any random put together, like a couple of devices and a cheap gigabit switch, you'll probably see 850 to 950 megabits on an iPerf3 connection between the two. But again, that's not what it looked like for the first 5 years or so of gigabit, being out there in the real world. I think that 2.5 gigabit has kind of a similar problem in that it's not really achieving, everything that it claims that it can on the package. But what it's claiming on the package is not a 10-fold increase. It's already only, a 2.5-fold increase. And I don't think that was big enough to move the needle enough to make business environments go for it. Because in business environments, you've got more of a pressure to actually test the thing and trial it and see if it does what you want it to. And nobody's finding that those things are doing what they want them to.
Well, I think also in business, if you're going to upgrade the switches and all the infrastructure anyway, only going up to 2.5 didn't seem to make sense versus going to 10 or 25 or 40 gigabit. Because the other thing is, really to Jim's point, the drivers for these new devices are maybe not as mature. Like you can get used Mellanox 10 gigabit stuff that was when it was mature, but is still 5 or 10 years old now, and get the full 10 gigabit for cards you can get off on eBay for $15 or $25. And my basement rack is full of those Mellanox cards, like the ConnectX 3s that are ConnectX 2s that are super old, but they can saturate the whole 10 gigabits. Whereas, all this 2.5 gigabit stuff is still pretty new and the drivers aren't as mature. And even the hardware is like, well, we're trying to make this as cheap as possible, right? At the time, the Mellanox was like, no, this is a premium product. This is like the best thing. We're going to put all these extra horsepower in these big chunky cards. Whereas the 2.5 gigabit is like, we want the built-in Ethernet on your motherboard that we make as cheap as possible to have a bigger number so that you'll buy it.
The other thing I'll warn anybody that's interested in getting into all this, it's really cool and exciting to get into 10 gig or faster networking when all you've done is gigabit up until then. And gigabit has been a thing for so long that I know for a lot of folks, it's just like that's the speed that wired networks go. And the idea of, I can go 10 times faster than that is like super exciting. And I'm not telling anybody not to play with that, but I am going to say, I'm going to share that there are 2 different types of storage admin. There's the 1 gig storage admin who thinks performance doesn't matter because the network's always the bottleneck. And there's the 10 gig storage admin who very quickly discovers, holy shit, everything matters now. Because it is so easy to get yourself in a situation where your network will go faster than 1 gigabit, but your storage won't. And as a result, you don't see any actual real world difference. So be aware that going 10 gig can be a little bit of a rabbit hole you end up diving down, and you may end up upgrading a lot more than you thought you were going to have to before you really see that 10 gig benefit the way that you wanted to.
My shuck drives suddenly feel very seen.
I just finished a consulting gig for a video post-production house. And they're like, all right, we've got our file server with 100 gigabit NIC in it. It's connected to like 4 or 5 different editing bays with a mix of 40 and 100 gigabit. And we need to be able to do like 2 or 3 gigabytes per second from each of 3 or 4 workstations at once from this NAS. Each frame of the video is a separate file that are each like 30 to 40 megabytes. And we need to be able to stream these without any stuttering. So we need to be able, it's got to be sustain this many gigabytes per second. It doesn't need to be more than that, but it needs to be this many and never fall below that many. And that's a lot harder to do than just installing a bigger NIC.
You got to get your storage dialed in. You got to have your compute dialed in, because when you're feeding that much network throughput, you need to have the PCI Express lanes to read from your storage fast enough, as well as, the storage itself being fast enough. So, you've got CPU issues, you've got storage issues, in addition to just throwing a faster NIC at it. If you're doing Ethernet, like, you're going to have to configure jumbo frames, and that's going to be weird and different between different operating systems. Like, I just had to mess with all that this weekend for a client that did a 10 gig upgrade and didn't get the benefit out of it for exactly the reasons we're talking about. So I spent the whole weekend in there messing around with jumbo frames, discovering that, with certain configurations, their Windows clients would just plain crash, even though everything was configured the way it should be with, 9,000 byte jumbo frames all the way around. Like, there's so many ways for it to screw up. Like on Windows, to get a 9,000 packet frame, you actually have to set it at 9,015, because Windows also includes the 15 byte frame header on every frame, whereas every other operating system doesn't count the header when, they're adding together the number of bytes that go in. So it is a giant pain in the butt. It can be done, but just, again, I'm warning everybody out there, this is not a casual project. It can get away from you quick.
Yeah, and especially when you're aiming, like we were aiming for a certain level of consistency. It's like, so it needs to not just be fast, but not have any latency spikes. Right? We have to have enough headroom that we can absorb a spike and not ever have the transfer rate fall below the number of frames they need to be able to get per second to play it back smoothly to make sure it's coming out right. And it really is, like I've done on a server as big as 2 dual ported 100 gigabit cards. So that was 400 gigabits total, pushing out of a 128 core machine, and just proving that it could take video files from RAM and chuck them out the network, SSL encrypted at 400 gigabits a second. And that took a lot of tweaking and tuning. And the biggest thing when you're getting to any of these higher numbers beyond a gigabit is you usually need more than one flow. One TCP connection is not going to saturate your 10 or 100 gigabit network card, because you're going to run out of CPU power, because one flow can only use one core. Whereas if you make 10 connections, then each of those 10 connections can execute on a different core at the same time and have a different interrupt channel from the NIC, and you'll be able to do it. And so for the video editing thing, we had to make each client be using 16 threads so that we're pulling this frame and the next frame, and each in a different thread, so that we would have enough flows to actually be able to deliver that much bandwidth, because you couldn't do it with just a single NFS connection.
Right, well, we'd better get out of here then. Remember, show@2.5admins.com if you want to send in any questions or your feedback. You can find me at joelrest.com/mastodon.
You could find me at jrs-s.net/social.
And I'm at Alan Jude.
We'll see you next week.